2.2, number 96. Length of a shadow. A child 4 feet tall standing near a street lamp that is 12 feet tall. They give us a sketch, which is nice. The light from the lamp casts a shadow as shown. So this is the shadow right here. So L represents the length of the shadow. Find the length L of the shadow as a function of the distance D of the child from the lamppost. So we want to find this length written as a function of D. So it's going to be L of D, or L equals D stuff. Okay, so we need to, I'll finish answering the question, to use the fact that ratios of corresponding sides of a similar triangle are equal. Okay, so this is another similar triangles problem where we have two similar triangles. We have a small one here and we have a large one. So labeling them, we know this is L and this is 4. This is L plus D and this is 12. Okay, since they're the same shape, they're similar, so the corresponding sides are, the ratio is the same. So you can do 4 is to 12 as L is to L plus D. You could do L is to 4 as that is that. It doesn't matter. So I'll say L is to 4 as L plus D is to 12. So that is our equation relating the two variables, and we're solving for L here. Okay, so I'm going to start by cross multiplying. And we need to get L on one side. So I'm going to subtract 4L. 8L equals 4D. And divide by 8L equals 4D over 8, or 1/2 D. You could also write that as D over 2. Same thing as 1/2 D. So that's our answer. L of D, written in terms of D, is 1/2 D. Alright, what is the domain? Well, domain is possible x values, in this case possible d values. The smallest the distance could be from the child to the lamp is 0. And I suppose it's possible that he's just touching the lamp, so the smallest would be 0. And he could go out forever. So, you know, assuming the earth is flat, that you could just go out forever. So I'd say from 0 to infinity. It's not realistic in this case that it would be infinity, but where do we end it? We'll just say it goes to infinity. Okay, so if I was going to write it not in interval notation, you'd say x is greater than or equal to 0. That's our domain for this problem. And then the length of shadow when 8 feet from base. 8 feet from the base. This is our distance from the base, that's D. So our length, or L of 8, is 1/2 times 8, so it is 4 feet from the base.